okay, good morning. This is the question we left for you yesterday, number 8. Here's the answer, right? We have x squared times e to the power x minus 2 times e to the power x less than 0, okay? So this is, of course, is an if statement. So we factored. And if the e to the power x multiply x squared minus 2 is less than 0, then x squared minus 2 must be less than 0, because e to the power x is always positive, no matter what the number x is. Okay, so e to the power x is always positive. So you can say, oh, I'm going to multiply both sides by e to the power negative x. So however you do it, okay, or you can say, I'm going to divide both sides by e to the power x. You certainly can do that. Okay, if you divide both sides by e to the power x, it's going to be positive. It's, you know, e to the power, because e to the power x is a positive. Therefore, you can, and as a result, we will be able to get the next step. So it's all because this reason. Okay, it's all because of this reason. So this is the reason that. This is the reason. Then from this step to the next step, okay? And you don't need to show this step, because logically you can also say if a positive number multiply another unknown number is negative, then this unknown number must be negative. Okay, so the rationale is that, so if you remove this line entirely, right? The rationale would be the following, okay? If the product of a positive number and an unknown number is negative, right? If the product of a positive number and an unknown number is negative, then the unknown number must be negative. Okay, think about it. So the rationale between these two steps, okay, from this step to the next step. Okay, so one rationale is if the product of a positive number and an unknown number is negative, right? So how do we interpret this? So let me put this here in the notes for your convenience. Okay, between these two steps, right? Between these two steps, between these steps, and these are 2 steps from here to there. Okay, one of the reason, okay, oh, I just crossed it out. Okay, if the product of a positive number and an unknown number is negative. You understand what I mean? This is the product of a positive number and a number that we don't know. So in this case, what do we know is that we know A times B is negative. Okay, if A times B is negative, and we also know A is positive, then what can we say about B? Then B must be negative, right? Then B must be negative. So that's the reason. That's the reason we have to think about what is the narrative? What is the narrative, right? What is the context, right? So if the product of two numbers is negative, and we already know one of the number is negative, so of course the other number must be negative, right? So this is the between these two steps, okay? Between these two steps. Okay, if the product of a positive number and an unknown number is negative, it is certain that the unknown number must be negative. Okay, I hope you guys understand that. Okay. All right. So if the product of a positive number and an unknown number is negative, because this is an if statement. Okay, if a positive number times an unknown number, right? We know this is a positive already, and we just don't know this number because we don't know X, right? So we know the product is negative, and one of the numbers is already positive. Of course, the other number must be negative. Okay, that's the rationale. That's the rationale. Okay, now, once we get to this step, and then we will subtract, we'll add 2 on both sides, take square root on both sides, okay? Take square root on both sides. You can skip that step. You can skip that step. Okay, because we have known so much, we have done so many times, right? So the absolute value X, the absolute value of X is less than √2. And of course, that's inequality. So X must be between negative √2 and positive negative √2. Okay, so that's note 1. Note 2. Note 2. It is a mistake to do the following. Okay, so from here, okay, so if the product of two numbers is negative, then if you go ahead to say, oh, e to the power x is negative, okay, and x squared minus 2 is negative, if you do this, whether you put an or and in between, they are terrible mistakes. Because think about it, right? If it were and, right? This will never be true. This will never be true. Besides, a negative times negative is positive. It's not going to be negative, right? You cannot retract your step. We cannot go back to our previous steps. And besides, we know that e to the power x is always a positive. So this claim itself is a mistake. Is a mistake. So please don't do that. Okay, use reason. Okay, we know e to the power x is always positive. So you can see, but if you use or, for example, if you use or, right, and this statement is obviously false, right, and this must be true. This must be true. But this statement obviously is completely redundant, because if this is true, and that must be true. Okay, so whether you use and or it's going to be logically flawed. It's going to be logically flawed. So don't do that. It's a mistake to do the following. Okay, so that resolved the question we have left off yesterday with the last question of 18a. Okay, it's the last question of 18a. So let's fast forward. Okay, let's fast forward. We have assigned basic 21 okay? Basic 21 was assigned. These are meant to be exercises for you to review some of the basic algebra course contents, okay? And so basic 22, I'm talking about the A's, right? Basic 23, 24, 25, okay? And these are the basic graph, 27, 28, 29, 30, okay, 30, 32, 33, 34A, and then we come to 35A, okay? Among these exercises, okay, I hope you guys go through them, okay? I did not stop there much, but if you have any question, you should ask, okay? Those are very basics. And I'm taking you directly to basics 35A, because these questions are going to show up on a different form for a different task in your calculus class, okay? So from basic 21 through basic 34A, these are preparing you to be able to do questions like 35A, okay? All right, so these are the basic, very, very basic operations. So please take a look, okay? Please take a look. And if you wish, I can go over some questions. So 35, so let me write it down. Basics 21 through basics 34A, okay? Cover basic concepts and the operations in basic algebra. Okay, so in this one sentence, see how many words of basic I have used. They're considered very basic. You are assumed to know. Okay, you're assumed to know. Okay. You're assumed to know. Do you know, right? The question is, do you know? Do you know, can you operate them fluently? Can you operate it without any issue? Okay, and if from time to time, you're going to encounter some issues in those sections. For example, I'm going to take some examples for you, okay, before we're heading to 35A. 35A, you're going to see those questions in the setting of calculus setting, for example, to find limit, to find to find whatever thing your calculus task you're going to do, you will encounter that. So whatever we do in this class for 35A is going to be just a few steps in your calculus class in order to fulfill your calculus tasks. Do you follow me? Okay, let me say it again. Whatever we're going to do in 35A is going to be, suppose we do it 2 steps, 3 steps, 5 steps in 35A, okay? Some of these questions are exactly the same question from your calculus textbook. So what we do here is just a few steps to fulfill your tasks, which is more steps in your calculus tasks. So we're doing the algebraic tasks here. Okay, so before we do 35A, you should be able to do well with basic 21 through 34A. Okay, so please do go over them. So for example, I'm going to give you some very simple ones, right? You might encounter this in calculus 2. Okay, I'm not even talking about calculus 1. You might encounter this in calculus 2. Okay, so this is on basic 33. Okay, of course, there are other issues this is basic 33 and number 1. Okay, and then I'm going to give you number 2. Try those. Can you simplify them? Okay, this kind of thing may show up in the last step, of your calculus task. Okay, suppose you're doing integration. In the end, you get something like this. I'm not saying exactly, okay, similarly. Okay, similarly. And the cubic root of 16 plus cubic root of 54. Excuse me, 54. Can you handle these operations to complete your last steps in your calculus tasks? Can you do that? You should be able to do it. You are totally expected to be able to do that. Okay, in fact, a lot of your peers in the class probably is doing it. Okay, so try that. Okay, so we have a number of questions, and there are some other very basic. I would say I cannot emphasize the word basic more. Okay, I put this title in the basics. I mean basics. I mean they're very basics. Okay. Can you do that? Just simplify. Okay. And you're not expected to use a calculator because those professors who teach calculus classes, in this kind of operation, they don't want you to use a calculator, and some of them don't even allow calculators on exams. Okay, I mean some of them. Okay, and some people will say, no, give precise answer. Give precise answer. Give precise answer means what? They rule out the opportunity of using calculator, right? Because a calculator give you approximations in many cases. Okay, I'm not saying in all the cases, in many cases, right? So things like that. Okay, another one. Okay, number 13. So some places I did not stop I did not do it. Okay, especially between basic 21 and 34A. I did not stop. I didn't spend time there because they're considered so basic. Even I assume you guys know it, but I could be wrong. So I want to fill up that gap in case there is a gap. And I noticed that my math 80 class is very much under enrolled. Okay, a lot of people, they flock to pre-calculus class, but some of the skills they need is in math 80. So the topics we talk about here, basic 21 through 34A, those are typical math 80 contents. Okay, those are typical intermediate algebra, college algebra contents. But some people, because now you can choose classes without having to pay respect to prerequisite, sometimes you might have skipped classes you shouldn't have, which is fine. That's your right. And but you might be struggle with some of these gaps. You may or may not know. Okay, so I have assigned those exercises. Just because I didn't test you and I didn't spend time in class, it doesn't mean you get it. So you have to spend some time on it. Okay, and also the other one, right? This one, people like me who taught the calculus class, we knew this is a common. Okay, this is a common, right? So did you guys do those? Let me see how well you do it. So your calculus class is full of trigonometry, is full of exponential functions, is full of a natural logarithm, it's a full of, you know, so oftentimes you're going to see these radicals throughout your calculus classes. They just pop up. They just pop up. Let me see how well you do. Okay, there's no judgment. Okay, and I'm not grading you on this. And some other exercise here. I'm just going to pick some because today is support class, right? Today is support class. All right, so I'm going to pick one from 22A. Number 1 and number 2. These exercises are from pre-algebra. Pre-algebra. Okay. This is the exercises from pre-algebra. Okay. I found these exercise. I didn't create these exercise. Okay, I found these exercise by an author, okay, who wrote pre-algebra textbook by Tussie. Okay, the Tussie textbook. Okay. And I thought these exercises are very good. So I put these exercise in all of my algebra classes. Okay, and some of these graphing, okay, shifting, and of all sorts. Vertical left, right, top and bottom, right? Another exercise I'll pick up is from basic 30. 30. Very basic, right? Very, very basic. So the absolute value of x squared equals to the absolute value. Of course, we should know this by this time very well. And the cubic root of x raised to the power of 3 is equals to x. Okay. And basics 31. Basics 31. I'm just picking up one of them. I'm just picking up one of them. This is number 9. So I pick up these questions randomly, and I put it on the screen. Okay, and you work it. You work it, and you submit any which one you want. I will check your work and I pointed out the mistakes. I personally, when I was teaching calculus classes, I've seen so many mistakes, so many basic mistakes at the pre-algebra level. At the pre-algebra level, and those are the places you lose points. Those are the places you lose points. Okay. It may be just 1 or 2 steps. Okay, the last few steps or the beginning few steps, and so on and so forth. Okay, so take your time to do that. All right. We got some submissions. Thank you, Bailey. All right. This is Bailey's work on the one of those exercises. And let's grade it. And Andy is submitting something. Okay, very good. Well, I'm gonna get to each one of it. Okay. So you're all welcome to submit. All right. The first one. Okay. It's good overall. It's really good. Okay. But put away these equal signs and put the equal signs over here. Okay. Write it this way. Okay. And remove these equal signs. Don't put it in behind. All right. So that's a perfect word. Okay. But you made a copy error here. You see, you wrote 1/3 to the power -1. So okay. So this should be just 3 to the power -1. Do you see that? The next step. Okay. If you keep 1/3 to the power -1, you have already made it. You would have made a mistake here because that equal sign is not validated. Okay, so this is 3. I regard that as a copy error. I don't know what is the source of the error. You just go from here to the next step and keep going, and the rest you did very well. So that's my corrections. Got it? Okay. So let's look at Andy's work. Okay, let's look at Andy's work. Let me do this. Andy's work there. Andy's work right there. Okay, right here. Okay, you need an equal sign. You need an equal sign here. Okay, and make this piece just a little bit longer. Okay, make it just a little bit longer. Okay, so cover both. And that's 2 times √3 minus 3 times √3. Very good. But here you should have a negative, isn't it? Right? Now, cubic root. Very good job, Andy. Very good job. I didn't see the mistake I saw before. Okay. Cubic root of 16 is cubic root of 8 times 2. Very good. Very good writing. Okay. Excellent. You were just missing some equal signs, but primarily this is very good work. This is very good work. Okay. I'm pleased. I'm pleased to keep going. Okay. Keep going. Are you guys still working on it? Keep going. The first 2. you know, there are two kinds of statement we talk about in mathematics, right? The first kind of statement is just a statement. When you work on a statement, okay, all of these I have here, they're just statement. You need to put an equal sign connecting them because you're telling the reader do you follow me? This statement is saying, it's saying something. What does it say? My internet is unstable. Just hold on, okay? Just in case if we fall off, you know, if we lost connection. Do you guys hear me?
Yeah.
Okay, good. Okay, I think my internet is better. It's okay now. Okay. So what does this mean? Right? We talk about there are two kind of structures of sentences in mathematical grammar. This is one of them. All of these we're talking about today, these are
Your audio is cutting out again.
could you say it again?
Your audio is cutting out again. The connection is unstable.
Okay, my audio keeps cutting off. I'm sorry. I don't know. Let's see. Let me check the internet. The internet is actually it shows all the bars are lighted. Is it better now? Okay,
Yeah.
thank you. It is saying, what did this say? Right, so when I see you guys either not putting equal sign there or have an equal sign on the tail, that's not the right way to express it. Okay, I'm gonna have a little discussion about this, but first let's tell you what this means. This is saying this expression, okay, this statement is the same as that statement. Do you follow me? It is saying this one, for this one is the same as the next one. Or this expression is the same as the letter one, because that's what the meaning of equal sign. You follow me? So you don't write, say, oh, when you write it this way, what does that mean? This expression and this expression is the same as. It doesn't read right, yeah? So you must put this equal sign in the front. I forgot if I have addressed this issue before. I was observing one of our colleagues' work, and this professor, she was teaching a elementary algebra class, and she was teaching the student how to do factoring. Okay, and she just systematically telling students, okay, for example, in this case, right? She just systematically tells students, give the answer. You don't need equal sign. Don't put an equal sign. In fact, I think that's the scenario, because all the work she had on the board is without equal sign. okay? I pointed out after, because we have this regular review of our teaching, you know, I will be reviewed by my colleague and I will be reviewed on my other colleagues' work, you know, teaching. And I point this out and she insisted on doing that. Well, that's okay, that's her academic freedom. And I take this question, there's nothing personal in this matter. There's really nothing personal in this matter, okay? I'm just saying some of the professors, they do things certain way, okay? And so I take this question, I thought, okay, I'm just not, I just don't know as much as in mathematics, right? You know, I suffer this forever, like lack of confidence in my mathematics. Okay, you may be surprised to hear that. I am. I'm confident in what I'm doing now when I'm teaching. But sometimes in other ways of teaching and people explain it, I'm ready to learn because I didn't know the other way or some other you know ways to do it. And I had this opportunity to be in contact with some professors in the four-year universities, right? So I raised this issue. I said, well, when you guys teach, do you put an equal sign or you don't put equal sign? Okay, do you put equal sign? You don't put equal sign. Right, it's a very small matter. I have to agree, this is a very small matter. And here's this other professor's reply, okay? This is actually a professor at USC, okay? He said, well, if you don't put equal sign, you're not telling the reader how these two are related. Sure, they're equal, but you didn't tell the reader that's the case. Do you follow me? By putting an equal sign there, you're telling the reader that this expression is the same as the latter one. So you have made a connection between these two. Do you follow me? Okay, so I investigated some more. And so this is my belief. Okay, I believe probably over 90% of professors are doing this. They want the equal sign. And I don't know what proportion, you know, 90%, I'm not confident about that number, maybe even higher. Okay, because all the professors I had in my academic years, we all use equal sign. So this is a for statement, right? We have only two kinds of statement for equals for statement. Okay, this is just a statement, you know, including functions and so on and so forth. Remember when we were doing quadratic, when we're making completing squares, we add a number, subtract a number, right? So those are the same category. You work on expressions, you just put the equal sign to your left. If the latter expression you write is meant and is equal to the previous expression, you just put an equal sign there automatically. This is more like a convention in mathematics. If you don't, the word is the same as will not be there because the equal sign meant, okay, this equal sign is a shorthand notation for a phrase. Do you follow me? So for that reason, I want to be conventional. I teach my classes, I teach my students so that their work will be okay with more than 90% of the professors in mathematics. Would that be agreeable with you? So you will not be bothered by losing a point or two, because I will be one of those professors. If you're missing too many equal signs in calculus classes, I will take points off. I will, I promise you. Just, you know, if you decide that you're not going to put equal sign whatsoever, then you should not take my class. Because I insist on doing the conventional things. Okay, most people will accept. And so I will not lose points because of not doing it. Is that clear, everybody? So that's the story. So I just let you know that, so I know you might have been taught by those kind of professors, right? They say, ah, no, don't put equal sign, don't put equal sign, okay? This is the first kind of sentences, right? We say the statement. The if statement, right? The if statement, so this is just a statement, right? When we factor, so this is a statement. On the if statement, you already either have an equal sign or not equal sign. Equal sign is present anyway. Equal sign or greater than sign or less than sign or greater than equal sign or less than equal sign or even not equal sign. Okay, so one of these is present anyway. But it is an if statement. It is an if statement. Do you follow me? And there are only these two kinds of statements in mathematics. No more. I promise you. I haven't seen any more. I have graduate degrees. So your choice. Your choice. Don't allow these minor mistakes or minor things to happen so that you lose a point or two. Do you want to? If you don't mind, I can say I can I can stop nagging you. I can stop nagging you. All right. So suppose you go to USC, you met that professor I talked to, you miss that equal sign, and he's gonna probably take a point off. Right? Because equal sign, this is what I come back to address. Every symbol in mathematics, they mean something. They have a specific meaning. Yes, we use a lot of shorthand notation, we do, but every symbol counts. If you're missing that symbol and that connective link is missing, that connective link is missing, okay? Anyway, so I'm making so much, you can say fuss about this. And because I have to explain this to all of my students, and I feel this need to explain it to you, especially I realize among our ranks, among my colleagues, some of people would do it differently, even though I disagree, but I want students to know that perspective, okay? I want students to know that perspective. And if I will tell my student, if there's an equal sign expected, you miss that equal sign, I will take points off. Right? So let's keep going. Keep going. Okay, keep submitting because my job is to help you. I'm not judging you, I'm just judging your work. I'm going to tell you what is right, what is wrong, and what is missing. Okay, so keep going, okay? I would like to see some more submissions. And right here, I'm just going to show that Bailey's work. Great job, okay? So let's look at that, Hasn't arrived. Let's see, hold on. Come on. Okay, very good. And this time, he did it perfectly. Okay, as picky as I am, no mistakes. Perfect. Okay, perfect. Okay, equal signs present. You're telling me this is the same as the letter, And the same as the letter, the same as the letter. Perfect work. This is the kind of work I wish you to do for all of your math classes. So you're not going to lose points from me. You're not going to lose points from anybody else. Okay, so let's strive for that. Let's strive for that. Okay, very good job, Bailey. Okay, good job, Andy. Okay, so I appreciate you guys submitting those work. I hope that will help everybody. Okay, so how about more submissions? More submissions. Do we have more submissions? On this one, on number 2, I'm gonna do it in a different way as Bailey's. You guys saw Bailey's work, all right? That's perfect, right? Okay. And I'm gonna show it just a slightly different way from Bailey's, which also works for your reference. And that equals to 2 times 3 equals to 6. Okay, so let's look at basic 30. Do you have any questions on basic 30? On these two, right? And there's a bunch of exercise over there. Shall we head into 31? Number 9. We did number 1 on basic 33. Number 2 on basic 33. Actually, Andy did them. He did a very good job. He did a very good job. And just missing a couple equal signs, and that's easy to fix. And number 13 hasn't been done yet, right? Number 13 hasn't been done yet. So we have number 9, number 13. I want to see your work on these two before we're heading to 35A. Excellent. Okay. Hold on. Okay, there. Oh, it doesn't show up. Okay. Got it, Bailey. Thank you. All right. Very common, very typical. Very typical. Okay. Thank you for sharing this, Bailey. Okay. The first step you did, okay, you recognize this is a perfect square. That's very good. That's very, very good. But the next step, you have made a fatal mistake. Okay, you have made a fatal mistake. Okay, it should be absolute value of x minus 5. Okay, and you're done. You're done. By this time, you're done. Okay, so at this point, you're done. And this one, there's no reason for that one. Because this is a statement. This is not an equation. You follow me? So I don't know how you get that, how you get there. It seems that you assume x minus 5 is equal to 0, right? Because only if you assume, only you have, if x minus 5 equals 0, your next statement will be x equals to 5. We don't have that. We did not have that if statement. We just have a statement. Do you understand what I'm saying? We don't have that. This is not given. This is not given. Not given. Okay, and yet the work you have shown here is a very common mistake. It's a very common mistake. I'm really grateful that you shared this, right? When you're given an expression like this, it is just an expression. It is a statement. Okay, it's a statement. It's a description of a rule. Say, oh, I'm taking square root of x squared minus 10x plus 25. And you are telling the reader, this guy is the same as the next guy, and the next guy is the same as the last one. You follow me? We do not give you if statement, so you have no reason to get x equals to 5. But yet, I don't know, for whatever reason, this mistake is rampant. This mistake is rampant. So please don't do that. Please don't do that. Okay, you're changing a statement to an if statement for no reason. Okay, for no reason. Okay, so thank you for sharing that. So I'm going to address this issue. Okay, let's come back to see how we do all of these questions on 31. Okay, they're all similar, so I'm going to just do one of them. Okay, first of all, this is just a statement, right? You see what's in the given, right? There's no sign of if statement. There's no sign of if statement. So if you create an if statement, you have to know it has to be given you a certain condition. You create an if statement. Okay, so here we recognize it's x minus 5 squared and taken square root. Okay, there are a variety of other mistakes, but luckily you did not make those mistakes. Okay, I'll see them if I'll tell you if I see them. And x minus 5. By this time, you are done. You're done. So this is why it's so important to recognize we only have two kinds of statement. One is the if statement. One is just a statement, just a plain statement. And this is just a one plain statement. And in your beginning algebra classes, your professor probably tell you, and this is called expression. Expression is that statement. Equation is that if statement. Is that clear? Okay, so for all of these 31, they're like that. Okay, they're all done similarly. Now, look at the comments I put there at the bottom of 31. What did I say? You'll be lucky if you see this kind of expressions in the middle of algebra tasks. Sometimes they show up in different statement forms. For example, they may show up like this. They may show up like that. Are you with me? And they may show up like this. They may show up like that. That's what I meant. And maybe T, it doesn't matter. It's just a form. It's just a form. Are you with me? So they may show up in different shapes and forms. Okay, as you can see, the absolute value, the square root of x squared, they show up in different shapes. And then when we did the work and we forgot to put absolute value sign, right? So what would you do here then? What are you gonna do? Right? If you want to simplify that, well, you're gonna get e to the power x minus 5 squared. Okay, and your final answer is gonna be the absolute value of e to the power x minus 5. If you're missing any one of these, okay, if you're missing the absolute value sign, which is a very common mistake, okay, common mistake, missing the absolute value sign. That's a loss of 2 points because that's a critical step. Okay, so what we are addressing in this question, the key of this question, right? What make this mistake, right? This is a common mistake, very common mistake. It's a common, it's not because it's always this exactly the same look. It could be a different look. Do you follow me? It could be a different look. So you have to imagine this X could show up in all kinds of balonies. Can you recognize them? That's the question. Can we recognize them? Can we see through them? Right? So let's look at the last one with the sign. I'm sure you already know what to do, right? I'm sure you already know what to do. And this one is interesting. Okay, this one has its own tweak, right? And you're gonna have sine t minus 5 squared. And then you're gonna get, of course, you're gonna get that sine t minus 5. But you can go one step further. How do we go that one step further? In your calculus class, you're expected to handle this one step further. Okay, I mean it because I imagine myself teaching that calculus class, I will do that. Okay, we know that sine of anything, we know the range of sine. Right? So sine minus 5 is always negative, right? We don't care what t is because this is true for any real number. Therefore, sine t minus 5 is always negative. Okay, so sine t minus 5 is forever negative. And the absolute value of a negative number is its opposite. the absolute value of a negative number, the absolute value of a negative number is its opposite. This is the capacity you're going to see yourself in. Are you guys with me? So you have to fully understand. So what is a narrative? What is a narrative? The absolute value of a negative number is its negative, it's opposite. And you're doing that. So the consequence after this sign t minus 5 is in place, you should get 5 minus sine t. If this is the kind of question you see that in a calculus 2 class, for example, you do integration, right? For example, you do integration. You reach it to this point, and your classmates may reach this point, and they finish an integration. They get full credit, and you don't. Do you follow me? Everything I explain here, you have learned. Yes, do you agree? Everything I explain here, you have learned. But this is the capacity of the work you are expected. This is the kind of work expected. And this is only the intermediate steps of your calculus tasks. Okay, don't get me wrong. This is just a little bit part of your, whatever you do, integration, derivative, and whatever you do. And they're called basic skills. Do you follow me? Okay. All right, so without further ado, we shall take a break, right? Shall we take a break? That was pretty intense, right? So what I want you guys to be able to do is to be really being strong, you become stronger in your algebra task. And so you can handle the calculus tasks. Okay, I'm not saying it's easy, but it can be done. It can be done. Okay, it can be done by doing exercise, by being mindful of what you do, being mindful of what we do. Okay, so after we come back, I'm going to address this question. I'm going to address this question. I don't know if you guys have done this, and then we're going to shift to 35A. Okay, we're going to shift to 35A. So take a break, come back at, please come back at 9:18. So I will see you soon. Okay, welcome back. Okay. We were just talking about that if we are given a statement or in the setting of expression, you will handle your work in that structure of sentence. Okay, you don't assume something happened, because that would turn into an if statement, right? If something. Even within the statement handling, like in this case, right? We are going to talk about this later, but in this case, okay, during the break, I was just sort of another scenario that might be related to it, okay? Suppose you're in a calculus class, right? Suppose you're in a calculus class. I'm not doing anything calculus, okay? I'm only doing the algebra part. And what happened is that you're doing, you need to drop the absolute value sign. You need to drop the absolute value sign. How are you going to drop the absolute value sign? Okay, suppose you are in a calculus class. Because if you don't drop the absolute value sign, you cannot possibly finish the task. Okay, your task in calculus require you to drop this absolute value sign, and you're in the statement setting. What do you do? What do you do? You are in this setting. How do you drop this absolute value sign? Right? Remember when we were doing absolute value? You know what I'm doing, right? The absolute value of a non-negative number is the same as the number. The absolute value of a negative number is its opposite. Okay, so in your calculus setting, these basics often pop up here and there. So how is it popping up here? Is it going to pop up like this? The x turn into a baloney. Okay, this x will turn into baloney. And what is that baloney? What is that baloney? Oops, sorry.
Not negative.
E to the power x to the minus 5, right? Right? So this is e to the power x minus 5. And so this baloney turn into that. Do you see that change? Right? Do you see that change? And then you simplify. E to the power x is greater than equals to 5. E to the power x is less than 5. And this turn into what? 5 minus e to the power x. And then you need to express it in x. So x is going to be larger than or equal to ln 5. X is going to be less than ln 5. Something like this. You need to know how to manage it to this point, and then you can finish your calculus tasks. Do you follow me? Whether it's integration or derivative and all of that. Because there's no formula to integrate this one or differentiate this one. Okay, you have to change them into these forms. Can you do it? This is from very basics, right? As basic as the narrative we had here. So I hope you understand why from these examples, I emphasize the fact that you guys need to practice and practice mindfully. Okay, because if you simply know this one without knowing how to apply it, that's not going to be helping you anyway. That's not going to help you very much. You have to think more deeply. And when you operate and work on those, you need to work on it mindfully. Right? And this is also related to the familiarity between e to the power x minus 5. Right? So why is this curve is so important? You need to have that vision. You need to have that vision, right? How is e to the power x minus 5 is created? You first create e to the power x, and you shift it down by 5 units. Do you follow me? Okay, you shift it down by 5 units. So this picture sorry. This picture, okay? So let me show you this. How basic it is, okay? I'm going to show you how basic it is. This is going to be 6, 8. That's the curve. That's the curve, e to the power x minus 5, right? Whether you do e to the power x or you shift it, however way you shift it, right? You know how to create this picture, don't you? When you need to sketch it, right? So it's a shifting from e to the power x. If you grab e to the power x, you know that how that is shifted. You need to quickly you should be able to quickly, you know, process that process, you know, this is the e to the power x, this is e to the power x to the power 5. Now you have an x-intercept, y-intercept. And at this point, okay, if you work with e to the power x minus 5, you get this picture and you know the sign changes, right? You know the sign changes. So let me remove that red one. We don't need that one, okay? We remove that one. So the operation I had here, okay, so I'm gonna bring that picture to you. You see this step, this graph, okay? This graph. And the point of intersection, what is the point? What is the x-intercept here? I want to show you the different perspective, okay? So now, e to the power x minus 5, we meant this piece is positive, negative. According to the positive and negative, you decompose e to the power x minus 5. Do you guys see that? Do you guys see that? Okay. And of course, there's a point of there's a point where sign change takes place, and you need to identify that point. What is that point? Can you guys tell me? After all we have said and done, what is the x-intercept here?
Natural
What is the
log
x-intercept here? Huh?
Natural log 5, 0.
That's right. Wonderful. You got it. Okay, so that's the point of above it is positive, below it is negative. And according to these systems, sometimes when you have that picture in your head, because it's just only positive or negative, right? It will help you tremendously. It will help you to visual. Okay, to help us to visualize that process, right? Or another perspective. Okay, I wish to give you another perspective, which we also talked about before, right? Remember this one. Suppose I don't do e to the power x minus 5, right? I'm just going to do e to the power x. How about that? No problem. Right? Suppose you say, oh, I don't have a calculator, or so on and so forth. I'm just going to do e to the power x. I'm just going to do e to the power x, right? And I'm going to delete that, right? This is e to the power x. It's just different perspective. And you reach the same goal, okay? You're going to reach the same goal, okay? Sometimes it's a matter of personal preference, right? So what is that 5? That crossing, what is that crossing? Because we're talking about e to the power x minus 5, right? So e to the power x minus 5, so that's above this is a positive for e to the power x minus 5, okay? Do you guys follow me? This will be positive for e to the power x minus 5. and the other one will be negative. So everything is relative. Do you follow me? Okay, this here is positive, then that's negative. So crossing. And what is this crossing now? Tell me, what is the crossing now? What is the point of, what's the crossing here? What's this point?
Natural log
follow me?
5.
That's right. You got it. Do you see that, you know, so much, there's so much thing that could be there that's showing up in your path. Okay, sometimes it may not be exactly the same question, but you need to have that. You cannot afford to be rigid, right? You have to be flexible. You have to look at from all these different perspectives, the graph, right? Remember the method I talk about, right? This method, algebraic method, you know, graphing method, and they all give us different perspective, and they all have the possibility to open our mind. Does that make sense? Okay, so without further ado, let's look at the, okay, we actually going to, in the latter part of the class, I will be addressing, you know, how to turn this into pieces, okay? Turn into similar things to pieces, which is similar, you already see it here, okay? We addressed that one. So let's look at 33. 33, Andy did a great job on number 1 and number 2, and we have done the corrections. So let's just look at 13. Okay, thank you everyone for your contribution and the participation. Okay, this makes it more interesting. Now, did anyone do this? You want to submit and show me? Anybody want to submit and show us? And of course, you know what I'm going to do. Okay, I'm going to check your work. I'm going to check your work for everybody. No one? No one? All right. In this case, we have x squared plus 1. And the square root of 81 is 9. And that's out. And you're done. You can do nothing more. You can do nothing more. Guess what kind of mistake we see in the past? We see all kinds of mistakes. Okay? Common mistakes. Common mistakes. What are the common mistakes we've seen?
Professor, I got a different answer.
You have a different answer. Oh, would you like to share that with us?
I got 9x plus 9. Well, that's what I put.
Okay. So is this what you did? Is this what you did? It sounds like it.
Yeah.
Thank you for sharing that. And that is a very common mistake. It's a terrible mistake. I'm sorry, Andy, to tell you. It's a terrible mistake. You can't do it. But it feels very intuitive to do it, isn't it? And isn't it? So when you were doing it, you probably full of confidence doing it, right? That's why I see this mistake so often. No, absolutely not. Why? Regarding root, okay, square root multiply b equals to square root of a multiply square root of b. Okay, that is true. Okay, so let me put it here. True. Okay, another case, square root of a divided by b is equals to square root of a square root of b those are true. Now, what are false? A plus b equals to root a plus root b. You have a counterexample for it. Everyone should have a counterexample for it. Okay? Very common mistake. If you have subtraction, those are false too. And these are not only true for square root, it's for any root. Okay, for any root, right? For example, if I have root of n ab, these are true, okay? Root a, root b, n, that's true. Okay, let me emphasize that, that's true. Okay, false. Okay, I want you to think about the counterexamples. This will be false. That would be false. And same with subtraction. You guys follow me? False, false. So what you did there, you made that mistake, didn't you? Then the question is, why are these false? How I wish that is true. I'm sure you wish that is true, right? Why is this true? Why this is a false? Right? Counterexample for that. Counterexample to this. Okay, I'm going to give you A equals to 9, B equals to 16. Check it for me. Check it. So for the roots operation, you can only do multiplication and division. Okay, the roots of product is the product of roots. The roots of quotient is a quotient of roots. Okay, I will write it down for you in a second. Okay, so first check this one. Be convinced that this is false. Be convinced that this is false. Left-hand side, right? Root of 9 plus 16. That's going to be what? Root of 25, right? We're very familiar with this Pythagorean theorem, right? Equals to 5. And what's on the right-hand side? 9, 16. Equals to 3 plus 4 equals to 7. Is 5 the same as 7? Of course not. 1 false, 1's false. Yeah? False, 1's false. So are you gonna use that again? Never. Never. Never again. Okay? So if these are false, of course these are false. Okay, for the truths I'm gonna give you here. Okay, the nth root, a over b, there. So let me write it in words. Okay, write it in words. Okay. The roots of product is the same as the product of roots. Does that make sense? The roots of product, this is product, is the same as the product of roots. So these spells out the difference. Oh, they're the same. They're the same. Okay. The roots of quotient, provided the denominator, of course, is not 0, is the quotient of roots. Okay, so these are saying that they're true. But the roots of sum is not the same as the sum of roots. You follow me? But the roots of sum is not the same as the sum of roots. Okay, so handling the roots is another category of questions that you will encounter. Okay, you will encounter. Okay, so let's continue this. Okay, so please, you guys know, don't do that, right? Don't do that. This is a terrible mistake. This is a terrible mistake. Very common mistake. Very, very common mistake. Okay, and there are all kinds of other things, but this is one of those typical one. Okay, so I make it just singular mistake. So finally, we get to handle 35A. Okay, so let's move on to 35A. 35A is calculus 1 for real. Okay, the steps we are going to perform here is going to be part of your calculus tasks. We're only doing the algebraic part. We're only doing the algebraic part, which is to rationalize the numerator. Okay, so you can see before 35A, there's a 34A, and that's rationalize the numerator, the denominator. Okay, so I skip that part. I'm going to rationalize the numerator. Okay, we're going to rationalize the numerator is a very common task in calculus work you need to do. Okay, for example, in the chapter of derivative, you might encounter something like this. Okay, that's our first one. We're doing the algebraic part of this calculus task. Okay, so we're not doing calculus task. Your calculus professor would take you to do that. Okay, so what do we do is that we're going to rationalize the numerator. Then you say, why? Okay, why will be explained to you by your calculus professors. I'm not going to explain that to you. I'm not getting into that. Okay, so for the reason to be explained to you, we're going to rationalize the numerator. So here are the algebraic steps. Okay. You are going to multiply. Okay, in order to get rid of the radicals, you're going to multiply by 1. Okay, so you're going to multiply by 1. Like bologna over bologna, right? So what the principle is that? Anything times 1 stay the same. Principle number 1, right? Principle number 1, anything times 1. Remember, this is an expression. This is just a statement. This is not an if statement, okay? This is a statement. So you're going to choose something to make that radical disappear, okay? So what is that something you're going to choose? You're going to choose the conjugate of the numerator. The conjugate of the numerator is simply just turn -2 to +2. You follow me? So that's the bologna you're going to multiply. So that still follow the principle number 1. Anything times 1 stay the same. And you're telling the reader, this statement is the same as the next statement because you multiply by 1. You follow me? Every symbol I wrote here is the exact way I wish to see in my students' work. Okay, conjugate. So why doing this conjugate? Right, you've learned this in algebra classes, and we have reviewed this, and so now what you need to do, we are creating a scenario which is a minus b times a plus b. In this scenario, you're going to get a squared minus b squared. That should be pretty familiar to us, right? That should be pretty familiar to us. Okay. So if we can do that, we will be able to get rid of the radicals. Okay, we'll be able to get rid of the radicals. Okay, so now we have a minus b times a plus b. So the next step, view this step as optional. View this step as optional because you could just so the numerator times numerator, denominator times the denominator. And because we're creating this scenario, so this scenario is being created. This is a preview of your calculus class, okay? This is a preview of your calculus class. Now, equal, on the numerator, we can apply that formula, can't we? So denominator stay the same. Don't change, don't multiply. Okay, just keep it that way, okay? Keep it that way, please. Don't multiply. The numerator, you're gonna get 4 plus h squared minus 2 squared by applying this formula. Do you guys see that? And next, don't do the FOIL. I know some of you have the tendency to do the FOIL. Don't do the FOIL. Use this formula directly. Could you do that for yourself? It will make your work look so much cleaner. Okay, of course you have to do the FOIL, go for it. But in my opinion, please, if you can help it, practice this formula over and over again so you can use it just like that. Okay, so you can actually go, so I view this step as an optional step. This step is an optional step. Okay, you don't have to show this step. You can go from here directly there. Next, you keep the numerator. You keep the denominator, I'm sorry, you keep the denominator and the numerator, you're gonna get a 4 plus h minus 4. Okay, I'm gonna explain this step. Okay, because here, there's another very basic minor step, but it can be a big step. Okay. If you have square root of x and you open parentheses, root of x, and you square it, it equals to x. But if you have x squared, that is equals to the absolute value of x. Have you noticed that? Do we know the difference? So it's basically square outside or square inside. What is the difference? Okay, I'm going to explain you the difference after we're done with this question, okay? So by this time, we're almost there. We're almost there, okay? Your part of your calculus task is almost over. Because you just do 4 minus 4, that's going to be just h left, and h reduced, and your final answer is going to be what? The final answer is going to be what? You will have just, you have an h, you have just, these are reduced, right? So you just, that's your final answer. This is only part of your calculus task, okay? You follow me? And next, I want to explain this piece. What the difference, why the difference. Basics. What's the difference? Why the difference? This is the difference. Why? Did you write down the work we had earlier? Okay, so why? Why? Why for square root we have such big difference? And we know that this is just often show up very often throughout your calculus series and after and ever after. Okay, we're talking about John and Mary live together happily ever after, and this is ever after, forever, right? And this is also forever, ever after. These are both true. True. So what is the fundamental in this difference? Yet it's so confusing, isn't it? The fundamental is because when we are handling, it's related to the flow. How we handle the flow. We should go back to function. Go back to function. Okay? The fundamental is in the flow. Okay, let's see how this is operated. Okay, root x is operated, the square is done later, right? So we first have x given as input, and then we do the square root of x. Right? The output, which is root x, square root of x. And then we square it. And this one, however, x is being squared. Okay, there's a square function if you wish. And then we take the root. And this difference cause what? Cause the domain difference. The domain here for this x, because this x is going to enter the root x immediately. So the domain must be x greater than or equal to 0. So to operate this guy, you start with x greater than or equal to 0. So how about the domain here? It can be any real number. The domain here is any real number will do, because you're going to square that number. Do you follow me? So when you deal with this expression, knowing that this x can be any real number, when you deal with this one, x already is greater than or equal to 0 to start with. That's why we have this guy, and that's why we have this guy. They are fundamentally different, and it all traces back to function. Do you follow me? And that is why when we do this, right? The square is outside. So 4 plus h is already assumed to be greater than or equal to 0. And therefore you have 4 plus h. Got it? Yep. All of these are very basic and very fundamental. Okay, so without further ado, we have 7 minutes left. I would like you guys to try your hands on number 3. On number 3. Okay, so this weekend your homework will be on basic 35A. Okay, try as many as you want, as you can. But we have covered lots of materials. Okay, lots of these are really, really fundamental. Try number 3 in class, please. Okay, you can do it, and you are doing it. How's it going? You getting there? Okay, so let me wrap it up. I do want to give you a closure. I'm sure you can do it. If you haven't finished, that's because I have to cut it short. You can continue to do that just to practice, okay? We're gonna multiply the conjugate. You guys know the word conjugate, do you? Yeah, the conjugate of the numerator. Okay, conjugate is a very simple concept in the way that a plus b, a minus b, they're called conjugate. Okay, they are called a conjugate. Okay, they are conjugates. Okay, anything in that form is called conjugates in general. And then we're gonna have the denominator. Don't multiply the denominator, okay? Don't multiply h with the inside. Just stay that way, okay? Keep my advice, okay? So x plus h squared minus root of x and squared. Okay, so let me make it a little bit larger so you can see better. Okay, and then almost there. There. So you have x plus h minus x. So in the end, you're going to have that reduced form. So h is left. And last but not least, all these h is reduced, right? So that's the final answer. Okay, this is literally calculus preview. Okay, all right. I will see you guys Monday. Okay, you've done a great job. Okay, participation, and I can see from the work you submitted, you are making progress every single day. Very proud, very, very proud of you. And I'm looking forward to seeing you guys on Monday. Okay, we're gonna have more fun. Okay, we're gonna have more fun. So thank you for coming. Have a great weekend. Keep on practicing, keep on deriving. You are going to be stronger. Okay, I promise you, because you are doing that. Okay, I'll see you on Monday, if not sooner. Do expect another quiz though. I will give you another quiz. Okay, let's look at the chat. Okay. All right, got it. Okay, thank you so much. Sometimes I'm behind on the chat. If you have any questions, please feel free to come to me, and I'll be in my office hours right after this. Okay, I will see you.
Thank you.
Thank you.